Hello students, welcome to this video. In this video, we will solve question number 31 to 40 of mathematical induction. The link to download the PDF will be in description, as well as at the end, I will show you how you can download a printed copy of books from the website. And I will also show you my question and answer web application, which I have prepared for you. So the thing is that YouTube is not suitable for asking mathematical questions, so you can use the website to ask the questions. Now, without further ado, let's get started. Question 31 says, let's show that 1 over 1 times 4 plus 1 over 4 times 7 and so on up to 1 over 3n minus 2 times 3n plus 1 is equal to n over 3n plus 1. So we let the given expression to be equal to P of n, and we put n is equal to 1. We get left hand side 1 by 4 and right hand side 1 by 3 times 1 plus 1. That is also 1 by 4. So Pn is true for n is equal to 1. We let it to be true for n is equal to k. That's why we have this equation. Okay. Now we add the next term on left hand side. We add 1 over 3k plus 1 times 3k plus 4. So we have got this pk plus 1, and right hand side becomes k by 3k plus 1 plus 1 over 3k plus 1 times 3k plus 4. And we solve this, we get finally k plus 1 over 3k plus 1 plus 1. And that's how by mathematical induction we have proven the result. Next one is a very famous equation, that is De Moivre's equation. We have to show that cos theta plus I sin theta whole to the power n is equal to cos n theta plus I sin n theta. I'm sure that we have done this in the complex number question theory, but let's see. So we let the given expression as P of n, we put n is equal to 1. So left hand side becomes cos theta plus I sin theta, and right hand side also becomes cos theta plus I sin theta. So it is true for n is equal to 1. We let it be true for n is equal to k. So cos theta plus I sin theta to the power k is equal to cos k theta plus I sin theta. Now we multiply both sides by cos theta plus I sin theta. So left hand side takes the form of pk plus 1. And right hand side becomes cos k theta plus I sin k theta times cos theta plus I sin theta. And we multiply, we get this equation, which is essentially equal to cos k plus 1 theta plus I sin k plus 1 theta. And that's how we have proven by mathematical induction. Give me a moment, I need some water. All right. So question 33 says that so that cos theta times cos 2 theta times so on up to cos 2 raised to the power n minus 1 theta is equal to sine 2 raised to the power n theta divided by 2 to the power n sine theta. So we take the given expression as Pn, and P1 is equal to cos theta, and right hand side is sine 2 theta divided by 2 sine theta. Now sine 2 theta is 2 sine theta cos theta. So 2 sine theta will get cancelled and we will have cos theta. So clearly this is true for n is equal to 1. Let it be true for n is equal to k. So we have cos theta times cos 2 theta up to cos 2 raised to the power k minus 1 theta is equal to sine 2 raised to the power k theta divided by 2k sine theta. Now we multiply both sides by cos 2 raised to the power k theta. Left hand side takes the form of pk plus 1, and right hand side becomes sine 2 raised to the power k theta times cos 2 raised to the power k theta by 2 raised to the power k sine theta. Now we multiply numerator and denominator by 2. So the numerator becomes sine 2 raised to the power k plus 1 theta, and denominator becomes 2 raised to the power k plus 1 sine theta. And thus by mathematical induction we have the result. Question 34 says that show that sine alpha plus sine 2 alpha to sine alpha is equal to sine n alpha over 2 over sine alpha over 2 times sine n plus 1 over 2 alpha. So we let the given expression as P of n and we put n is equal to 1. Left hand side becomes sine alpha and right hand side becomes sine alpha over 2 divided by sine alpha over 2 times sine 1 plus 1 over 2 alpha, which is equal to sine alpha. And thus it is true for n is equal to 1. Now we let pk be true, pn be true for n is equal to k. The left hand side becomes sine alpha plus sine 2 alpha up to sine k alpha. And right hand side becomes sine k alpha by 2 divided by sine alpha by 2 times sine k plus alpha by 2. Now we add sine k plus 1 alpha to both hand sides. So our left hand side takes the form of pk plus 1 and right hand side is this. Now once we have this, we break this sine k plus 1 alpha by 2 in the form of 2 sine k plus 1 by 2 alpha cos k plus 1 by 2 alpha. So we take sine k plus 1 alpha by 2 common, and in the denominator we have sine k alpha by 2 and divided by sine alpha by 2 plus 2 cos k plus 1 alpha by 2. Now we take LCM, and after taking LCM we solve it. Okay. So this 2 cos k plus 1 alpha by 2 sine alpha by 2 can be written as sine k plus 2 over 2 sine alpha minus sine k alpha by 2, and this gets cancelled. And thus we have the result by mathematical induction. Question 35 says that if a1 is equal to 1 and an plus 1 is equal to an over n plus 1 and greater than equal to 1, so that n plus 1 is equal to 1 over n plus 1 factorial. So we have this relationship given. So we compute A2. A2 is equal to 1 by 2, that is 1 by 2 factorial, which means it holds for n is equal to 1. Now let it be true for n is equal to k, that is ak plus 1 is equal to 1 over k factorial. Then pk plus 1 is equal to ak by k plus 1, that is equal to 1 over k factorial times k plus 1 or 1 by k plus 1 factorial. And hence by mathematical induction we have the result. Question 36 says that if a1 is equal to 1, a2 is equal to 5, n plus 2 is equal to 5, n plus 1 minus 6n, where n greater than equal to 1, so that n is equal to 3 raised to the power n minus 2 raised to the power n. So we have a1 is equal to 1 and a2 is equal to 5. Okay. So n plus 2 is, and it is given that n plus 2 is equal to 5, n plus 1 minus 6n. So we compute A3, which is equal to 5A2 minus 6A1, which is 25 minus 6 or 19, which is equal to 3 cube minus 2 cube, that is 19. Thus it is true for n is equal to 1. So this should be 1 because it is n plus 2. Let it be true for n is equal to k and n is equal to k plus 1. So we have ak is equal to 3 to the power k minus 2 to the power k, and ak plus 1 is equal to 3 raised to the power k plus 1 minus 2 raised to the power k plus 1. So ak plus 2 becomes 5 ak plus 1 minus 6 ak. So we have this expression now. Okay. What we have is 5 times 3 raised to the power k plus 1 minus 5 times 2 raised to the power k plus 1 minus 6 times 3 raised to the power k plus 6 times 2 raised to the power k. Now we solve this and we get eventually 3 raised to the power k plus 2 and 2 raised to the power k plus 2. So what we have done is you take 3 out of here, so it becomes 15 times 3 to the power k. 15 minus 6 is 9, and this becomes 5 to the 10, okay, times 2 to the power k, and plus 6 here, so minus 4, and that's how we have the result. Question 37 says that if u0 is equal to 2, u1 is equal to 3, and un plus 1 is equal to 3, un minus 2, un minus 1, so that un is equal to 2 raised to the power n plus 1, where n is in the set of natural numbers. So we have u0, u1 given as 2 and 3, and un plus 1 is equal to 3un minus 2un, and that we have to prove that un is equal to 2 raised to the power n plus 1. So u2, if you see, is 3u1 minus 2u0 is equal to 3 into 3 times 3 minus 2 times 2, that is 5 or 2 square plus 1. So it is true for n is equal to 2. Now we let it be true for n is equal to k and n is equal to k plus 1. So uk is equal to 2 raised to the power k minus 1 and uk plus 1 is equal to 2 raised to the power k plus 1 minus 1. 2UK plus 2 is equal to 3 times UK plus 1 minus 2 UK. And then we proceed like previous problem. We arrive at the final value of 2 raised to the power k plus 2 plus 1. And thus by induction we have proven the result. Question 38 says that if A0 is equal to 1 and A1 is equal to 1 and N plus 1 is equal to 3an minus 2an minus 1, then we have to show that n is equal to 2 raised to the power n minus 1. So it's a replica of the previous problem. Just like that, we solve. This is given to us. We compute A2 becomes 3, so it is equal to 2 square minus 1. So Pn becomes 2 for n is equal to 2. We let it to be true for n is equal to k and n is equal to k plus 1. So ak becomes 2 raised to the power k plus 1 and ak plus 1 becomes 2 raised to the power k plus 1 minus 1. Now we compute ak plus 2, which is equal to 2 raised to the power k plus 2 minus 1. So quite similar to 37. Okay. Question 39 says that if A1 is equal to cos theta, A2 is equal to cos theta, and for every natural number m greater than 2, m is equal to 2m minus 1 cos theta minus m minus 2, prove that n is equal to cos n theta. So we are given that A1 is equal to cos theta and A2 is equal to cos theta, and for every natural number m greater than 2, m is 2m minus 1 cos theta minus m minus 2. So we compute A3. A3 becomes 2a2 cos theta minus a1. So that is equal to 2 cos theta into cos theta minus cos theta, which is actually equal to cos 3 theta. Thus it is true for n is equal to 3. We let it be true for n is equal to k and n is equal to k plus 1. So ak becomes cos k theta and ak plus 1 becomes cos k plus 1 theta. And thus cos k plus 2 theta will become 2 cos k plus 1 theta times cos theta minus cos k theta. Then we write this as cos k plus 2 theta plus cos k theta minus cos k theta, which is equal to cos k plus 2 theta. And thus by induction we have proven that. Question 40 says that for any positive number n, show that 2 cos theta minus 1 times 2 cos 2 theta minus 1 and so on up to 2 cos 2 raised to the power n minus 1 theta minus 1 is equal to 2 cos 2 raised to the power n theta plus 1 over 2 cos theta plus 1. So we let the given expression as Pn, we substitute n is equal to 1, we get left hand side as 2 cos theta minus 1, and right hand side we solve, it becomes 2 cos 2 theta plus 1 by 2 cos theta plus 1, and numerator becomes 4 cos square theta minus 1 over 2 cos theta plus 1, which is equal to 2 cos theta minus 1, which is true for n is equal to 1. So we let it be true for n is equal to m, we have this expression, and we multiply both sides by 2 cos 2 raised to the power n theta minus 1. So left hand side takes the form of Pn plus 1 and right hand side becomes this. Okay. Now we solve this. Upon solving, we arrive at the value of 2 cos 2 raised to the power n plus 1 theta plus 1 by 2 cos theta. And thus by induction we have proven the result. So it's a simple matter of multiplying these two. So upon multiplication it becomes 4 cos 2 raised to the power m theta minus 1. Okay, and that is equivalent to 2 cos 2 raised to the power m plus 1 theta plus 1. So to understand this, you will have to know the trigonometric relationship, the transformation formula. So a lot of questions in this made use of trigonometry. For example, 39 also made use of trigonometry, 39, 40, 34, 33, and 32. So if you don't know trigonometry, you could have skipped that question, but we have done this. So if you don't understand this trigonometry-based question, come back to this once you have studied trigonometry. Now I'll show you my website. You come to astabaka.org. You can download the algebra, trigonometry, and coordinate geometry PDFs from here using second, third, and fourth link. The PDF will not have date. The reason is that if I put date in the PDF, then I will have to update all the YouTube links all the time. So come back here once every 15-30 days and see whether a new PDF has been uploaded. Also, if you want to ask questions, you can click the 8th link. That is Punjika. You can come and ask questions here. This editor supports math. So we need to know LaTeX math. And we can use the tags of algebra, calculus, trigonometry, probability, geometry, and coordinate geometry, and I will be able to answer your question. in most probable case, no guarantees. Okay, so make sure that you share with your friends, and I'll see you on Pumjika when you ask questions. Okay, this became that. So thank you for watching the video. I hope that you are enjoying this series of videos on mathematics, that is the entire algebra playlist. If you have not watched the playlist, then you should go ahead and watch the entire playlist. There are lots of problems solved in this video, this series of videos. So once again, thanks a lot for watching the video, and we will meet again tomorrow with 10 more problems of permutation and combination. Have a great day, study well, and enjoy.